The moon holds secrets that could rewrite humanity's future in space. But what if the greatest prize isn't where we thought it was? And what India uncovered there is forcing us to rethink everything about surviving beyond Earth. In the race to claim the moon's hidden treasures, one nation surged ahead and touched the most enigmatic frontier first. India didn't just land near the lunar South Pole, they pierced its mysteries with precision and persistence. Their findings are reshaping our understanding of water, the moon's electric skin, its ancient fury, and the fragile path to building homes in the void. This isn't just data. It's a revelation that echoes across every future mission. The story begins with the same instrument that first hinted at lunar water over a decade ago. India's Chandrayaan-1 orbiter, carrying NASA's moon mineralogy mapper, painted the poles in telltale blue, signs of water molecules and hydroxyl bound to the surface. Those detections ignited a global obsession with the South Pole, where eternal shadows might cradle billions of years of accumulated ice. Water means life support, breathable oxygen, rocket fuel. Without it, permanent presence remains a dream. Yet earlier samples from Apollo told a harsher truth. Water existed only in parts per million, tiny traces requiring vast processing to yield even a liter. The South Pole promised more. Nations converged there. But landings are brutal. Many failed. India pressed on. Their Chandrayaan-3 mission succeeded where others faltered. In 2023, the Vikram lander settled gently at Statio Shiv Shakti, roughly 600 kilometers from the true pole. This site, rugged with craters and illuminated only by grazing sunlight, tested every engineering limit. The achievement stands alone, the first soft landing in this shadowed realm. What Vikram found immediately challenged expectations. Plasma measurements revealed the moon pulsing with electricity. Charged particles swarmed the surface, creating microsparks and a tenuous exosphere. Solar wind bathes the dayside, while Earth's magnetotail drenches the moon for days each month, funneling radiation that ionizes regolith. This electric envelope, thin as a whisper yet dynamic, influences everything from dust behavior to potential resource extraction. Deeper surprises emerged below the surface. The Shasta probe drilled into the regolith, measuring temperature gradients. Surface readings hit 70 to 80 degrees Celsius under low-angle sun, hotter than anticipated. But heat vanished rapidly with depth. At just 10 centimeters, temperatures plunged to minus 10 degrees Celsius. The regolith acts as superb insulation, shielding subsurface layers from brutal swings. This confirms regolith's potential as construction material. Piled into habitats or sintered into bricks, it could shield against radiation and thermal extremes. To hunt for the ultimate resource, Vikram released Pragyan, a rover that roamed over 100 meters across the highlands. Its spectrometers, laser-induced breakdown and alpha particle, probed the soil's secrets. They detected aluminum, calcium, iron, chromium, titanium, manganese, silicon, and abundant oxygen. These elements hint at the moon's basaltic and anorthositic crust. But the standout discovery was sulfur, confirmed unambiguously for the first time at the South Pole through in situ measurements. Sulfur's presence carries profound implications. It ties to volcanic outgassing in the moon's distant past. Finding it in these bright highlands supports the giant impact hypothesis. A protoplanet collision melted Earth and flung debris that coalesced into the moon. Sulfur, volatile yet preserved here, offers a window into that cataclysmic birth. The rover searched relentlessly for hydrogen, the key marker for water ice. None appeared in measurable quantities at the landing site. No H2O signature emerged from the regolith analyzed. This absence echoed findings from other missions. Samples returned from nearby regions showed no clear water either. The blue patches on orbital maps did not translate to accessible ice at the surface. This forces a recalibration. Water ice likely hides deeper, in permanently shadowed craters where temperatures drop to minus 250 degrees Celsius, preserving volatiles for eons. These dark traps, untouched by sunlight, could hold frozen reservoirs. But accessing them demands new strategies. The extreme cold, perpetual darkness, and lack of solar power challenge even robotic explorers. Recent analysis of Chandrayaan-3's thermal data brings unexpected hope. Sloped terrain, angles greater than 14 degrees facing away from the sun, maintains subsurface cold enough for stable ice, even outside true polar shadows. Temperatures stay below freezing at shallow depths on these inclines. This expands viable zones dramatically. Ice might lie closer to illuminated ridges, easier to reach, less technically daunting than plunging into abyssal craters. The regolith's insulating power amplifies this possibility. A thin layer traps cold below while the surface bakes. Water ice could persist mere centimeters down in broader regions than once imagined. Future missions could target these slopes for extraction, drilling, heating, collecting vapor, without venturing into the harshest shadows. This shifts the calculus for colonization. Water closer to sunlight means reliable power, simpler operations, reduced risk. Oxygen from electrolysis, hydrogen for fuel, water for life, all potentially abundant in places machines can operate sustainably. India's discoveries ripple outward. They refine maps for NASA's Artemis, China's Chang'e series, and emerging collaborations. Upcoming missions, like joint efforts to drill directly into shadowed traps, build on this foundation. Robotic precursors will probe deeper, confirming concentrations and chemistry. The moon is not generous. It yields secrets slowly, demanding ingenuity. Each finding reveals harsher truths and brighter opportunities. Water exists, but hidden. The surface sparks with energy. Insulation protects what lies beneath. Ancient chemistry whispers of violent origins. We stand at the threshold of off-world permanence. The South Pole is no longer just a target. It's a puzzle whose pieces India helped assemble. The path forward requires persistence, collaboration, and the courage to chase the impossible. What will we build when we finally unlock these frozen reserves? How will this change who we become as a species? The answers lie ahead, waiting in the dust and shadows. If this journey stirs something in you, the wonder, the challenge, the dream, then keep watching, keep questioning, keep sharing these stories. Subscribe to join the exploration. Comment your thoughts on what the moon's secrets mean for humanity. Share this with someone who needs to feel the pull of the cosmos. Because the next chapter isn't just coming. It's being written right now, and we all have a part to play.